All right, guys, one more day of mathematical induction, part 2. This is going to be a really short video. I'm going to show you one example. Tomorrow in class, we're going to spend most of our time doing a certain type of math induction that's going to have to do with divisibility. I'm going to show you one example here. Just like my warning from yesterday, please watch it closely because all of these work about the same way. So if you get, let's say you get 50 to 60% of the video and you get that much of it, by the time we do a couple in class, I think you should be good. But really watch this only one example. Here it is. You got to show that 5 to the n minus 1 is divisible by 4 no matter what you put in for n, for any natural number that you put in for n. Okay, so just like yesterday, we got to prove it first with 1. So I'm going to put a 1 in for n. 5 to the first minus 1 is 4. 4 is divisible by 4, so it works. So the first case works. If you put it, think about putting 5. Let's just do this for fun. If I put a 2 in there, 5 squared minus 1, that'd be 24. You know what? That's also divisible by 4. So you got to prove that no matter what you put in, it's going to be divisible by 4. So I'm going to start this way. 5 to the n minus 1 equals, here's the key. I'm going to say equals 4 times, you can choose a variable. I'm going to choose k, 4 times k, meaning it equals 4 times anything. It's a multiple of 4. If it's divisible by 4, that means it's a multiple of 4. All right, so I'm always going to start off by moving that 1 to the other side. So I'll make this side say 4k plus 1. That's a key. All right, now, remember, just like yesterday, I'm trying to prove that it's true for the next term, past the nth term. So I need that n right here. I need that to be n plus 1, that exponent. And I'm going to use the rule of exponents, and I'm going to multiply that side times 5. Because think about what you do when you multiply the same base. You add the exponents. All right, so if I multiply the left-hand side by 5, I obviously got to multiply the right-hand side by 5. All right, so on the left-hand side, I get 5 to the n plus 1, which is what I want. Over here, I got 20k plus 5. All right, now, I need it to look like this, though. I'm looking for this, this pattern right here, with the exception of I need that n to be an n plus 1, which I have now, but the problem is I don't have that minus 1 anymore. And I had to move it over because if I didn't, this step right here when I multiplied by 5 would have been a mess. So I'm going to put the minus 1 back in there. And again, if I put it on the left-hand side, I've got to put it on the right-hand side. So my left-hand side now is perfect. All right, that's what I wanted it to be. The right-hand side now is 20k plus 4. Now the beauty of 20k plus 4 is that I can factor that. And when I factor it, I'm going to take out a GCF. And guess what the GCF is? It's 4. It's 4 times 5k plus 1. Now, I don't really care about that right there. What I really care about is that 4. Because if I put a 4 in the front, that means I'm multiplying this by 4 to get that, which means this right here is a multiple of 4. That's the proof. The proof is you get this side over here, you replace the n with the n plus 1, and the right-hand side, you show that it equals a multiple of 4. 4 times something. Doesn't matter what the something is, okay? Just that it's 4 times something because it's a multiple of 4. And those steps are what we're going to do in class tomorrow, mainly divisibility inductive proofs. That's fun stuff. All right, we'll work on it tomorrow. See ya.